Okay, so we're looking at your notes and trying to figure out what the equation of the graph that's given is. Okay, so there's going to be three things that in every one of these I'm going to ask you guys to try to find, like what the x-intercepts are, what the vertical asymptotes are, and also what the vertical asymptotes, or whether or not this has a horizontal or oblique. Now, when I look at this question, I know that they have an x-intercept. That x-intercept is at 0, 0. It's right here. Okay? And then I also know that if I look at this graph, it has a horizontal asymptote, or vertical asymptote, at x equals -2 and x equals +2. Now, how do I know it has a slant asymptote? Well, because there's a huge gap between these two graphs. That's one of the keys that I know. And then if I look, I could kind of imagine a line being drawn right here that would identify what, I think it's like the slant oblique asymptote actually turns out to be like y equals x in this case, which then tells us that the degree in the numerator is bigger than the denominator. So like I am probably going to have something like x cubed over something x squared eventually. Okay? All right, so we're going to take that information and kind of put it all together. I know that with this information, that is the vertical asymptotes always are impacted in the denominator. So I know that these are x plus 2. That's going to deal with that. And then I also know that it has to be x minus 2. Okay? Now this x-intercept right here, I'm trying to think of what can I have in the numerator, because the x-intercept deals with the numerator. I can have an x in the numerator. Okay? Because then that tells me that the x-intercept is 0. Now, if I look at this current state, right now I have x squared in the denominator and an x. Well, is the degree in the numerator bigger than it is in the denominator? Not yet. And the only way that I can get there is with an x cubed. So in this case, my function would be f of x equals x cubed over x plus 2 times x minus 2. So my vertical asymptotes are going to be dealt with on the denominator, and my x-intercepts are going to be dealt with in the numerator. Okay? All right, so let's look at this next one. This is B, 8b, in your notes. All right, so x-intercepts, I do have 2. I got 2, 0, and I got -2, 0. Horizontal or vertical asymptotes, it does look like I have one at, looks like it's x equals 1. Okay? And then if I look at the oblique asymptote, I know that I have, or do I have a horizontal or oblique? Looks like I have a line of right in the middle, like at, so I do have a horizontal asymptote, okay? And it looks like the horizontal asymptote is at y equals 2. So in that case, because I have a horizontal asymptote at y equals 2, I know that when I look at this equation, it's going to be the degree in the numerator has to be equal to the degree of the denominator. That's how we always get, if we have a horizontal asymptote at a specific number other than 0, that is always going to be the case, that the degree of the numerator is going to equal the degree of the denominator. So let's kind of take this information and try to write down what the equation is. So remember, we take the x-intercepts, that's going to be on the top, and then we have the vertical asymptotes are going to be on the bottom. So in this case, I have only one vertical asymptote. It's going to be x minus 1. And in the top, I know that I have x plus 2, and then I have x minus 2. Okay? All right, so the next thing that we got to look at is I need to make sure the degrees in the numerator have to equal the degrees of the denominator. Well, I have a degree 2 on top. That means I have to have a degree 2 on the bottom. So that means I have to have a 2 on the bottom. So now I have x squared over x squared. Now we have to deal with this horizontal asymptote at y equals 2. Remember, when we find what the horizontal line of asymptote is, we take the leading coefficient of the numerator and divide it by the leading coefficient of the denominator, and that's going to get us that horizontal asymptote. When I divide these two, I need to get a 2. So that means in this case, it has to be a 2 on top, because if I divide these, this is a coefficient of 1, that's a coefficient of 2. 2 divided by 1 will get me y equals 2. Okay, so this is your next function. Okay, f of x equals that. All right, so let's look at this next example. Okay? All right, so does this have x-intercepts? Yes, it has 2 of them. It does have one at negative 4, 0, and then it also has one at 1, 0. Does this have a vertical asymptote? Yes, it does look like that. And if I were to look at it, it looks like it's going to be at x equals negative 2. Okay, and does this have a horizontal or does it have a oblique asymptote? Well, because it's angled, I know that it has an oblique asymptote. So right now, I know this information. Okay, the x-intercept's negative 1 or positive 1, 0, and negative 4, 0, and it has a vertical asymptote at x equals negative 3. I know I have a degree oblique asymptote. The degree in the numerator needs to be bigger than the degree of the denominator. So remember, my vertical asymptotes go on top, or no, my zeros go up top, and my vertical asymptotes go on the bottom. All right, so if I look at my zeros, I do have x minus 1, and I have x plus 4. And now if I look at the bottom, I do have a point at negative 3, so it's going to be x plus 3. So if I look at this, is the degree of my numerator bigger than my degree of my denominator? Yes. Did I recognize the x-intercepts at 1, 0 and negative 4, 0? Yes. And then did I deal with the vertical asymptotes at negative 3? Yes. So this would be your final equation. Okay? All right, so let's look at this last one. A little bit different, but the same idea. So like we do want to find out what the x-intercepts and vertical asymptotes are, and whether or not it has a horizontal one. Well, in this case, I do know that it has no x-intercept. Vertical asymptote looks like it's going to be at x equals 3. And then it has a horizontal asymptote at y equals 0. So because it has a horizontal asymptote at y equals 0, we know that the degree of the denominator is going to be bigger than the degree of the numerator. So now we're just going to set this up in which we're going to say x-intercepts, there is none. I'm going to put an a there because there needs to be something there, and we just got to figure out what that is. And then in the denominator, I know it has to be x minus 3. So I got to find out what a is, and the way that we're going to do that is we're going to use this point, and we're going to plug it in. So I got a divided by 5 minus 3 equals 2. So I have a over 2 equals 2. So what does that get me a to be? It gets me to be a is 4. So in this case, my function would be f of x equals 4 over x minus 3. Hopefully this was helpful. If you guys have any questions, don't hesitate to ask. This will help you overall with the assignment that we're going to be working on. Thanks.